Bismillahirrahmanirrahim. Assalamu alaikum. We are going to start unit number 4, algebraic expressions and algebraic formulas. And this is our session number 1. In this session we will discuss origin of algebra, algebraic expressions, polynomial, notation of polynomial, degree of polynomial, rational expression, and then we will solve exercise 4.1, question number 1 and 2. Look at this page, Kitab al-Khwarizmi, a page from al-Khwarizmi's algebra. The English translation of this title is The Compendious Book on Calculation by Completion and Balancing. And its actual Arabic title is Al-Kitab means book, Al-Mukhtasir means compendious, Hisab means calculation, Al-Jabr means completion, Wal Muqabla means balancing. This book was written by Muhammad ibn Musa al-Khwarizmi approximately 820 AD. Al-Jabr, that is the short title of this book. And this book was a landmark work in the history of mathematics, establishing algebra as an independent discipline, and with the term algebra itself derived from algebra. So algebra means restoration or completion. Now algebraic expressions. Algebra is a generalization of arithmetic. Recall that when operations of addition and subtraction are applied to algebraic terms, we obtain an algebraic expression. For example, if we have three terms like 5x squared, 3x and 2, and we combine them with the help of subtraction and addition, then this expression becomes 5x squared minus 3x plus 2. This is an example of algebraic expression. And 3xy plus 3x, this is also an example of algebraic expression. Polynomial. Polynomial comes from poly, meaning many, and nomial in this case means terms. So it says many terms. A polynomial can have constants like 3, negative 20, or 1 by 2, or square root of 3. These are all constants. Variables like x and y. Exponents like the 2 in y square as y raised to power 2. So this 2 is exponent. But only 0, 1, 2, 3, so on, etc. are allowed. It means that exponents must be non-negative integers. A polynomial can have constants, variables, exponents that can be combined using addition, subtraction, multiplication and division, except not division by a variable. So something like 2 by x, here you can see that x is a variable and here it is divided, so this is not allowed. So a polynomial can have constants, variables and exponents, but never division by a variable. Simple thing, keep in mind. Notation. The polynomial function is denoted by p of x, where x represents the variable. For example, p of x is equal to x squared minus 5x plus 11. You can see that here the variable is x, so this is p of x, its notation. If the variable is denoted by a, then the function will be p of a. Degree of a polynomial. The degree of a polynomial is defined as the highest degree of a monomial within a polynomial. As you can observe, p of x is equal to x squared minus 5x plus 11. This polynomial has three terms. So in each term, you can observe the first term having raised to power 2. In the second term, x raised to power 1. And in the third term, x is missing. It means that x raised to power 0. So in these three terms, the highest exponent is 2. So 2 is the degree of this polynomial. Thus a polynomial equation having one variable which has the largest exponent is called a degree of the polynomial. Now some examples. The first one on the right top, 9. You can see that this is a single term. So a polynomial having single term is called monomial. We know that. And here 9, there is no variable. So the degree of this polynomial is 0. This is called constant or zero polynomial. The next one, 5x plus 8. You can observe it has two terms, 5x and 8. So this is binomial. A polynomial having two terms is called binomial. And in each term you can observe the first term having exponent 1 and the second term having 0 exponent. So this polynomial having degree 1, or this is called linear polynomial. The next one, 4x square plus x minus 1, and here the highest exponent is 2. So this is degree 2 polynomial and it is also called quadratic. And you can observe that this polynomial having 3 terms. So with respect to terms you can say that this is trinomial. The next one, 6x cube minus 4x plus 3x minus 4 having 4 terms and the highest exponent is 3, so degree 3, and it is called cubic polynomial. The last one, 6x4 plus 4x square minus 3x plus 3, degree 4 polynomial. Rational expression. As we are familiar with the rational numbers, any number that is written in the quotient form is called rational number. Similar as if we talk about rational expression, the quotient, you can see that p of x over q of x. So of two polynomials, p of x and q of x both are the polynomials, and where q of x, that is the denominator, is non-zero, is called a rational expression. So when two polynomials written in the quotient form, then this form is called the rational expression. For example, 2x plus 1 over 3x plus 8, where 3x plus 8 is not equal to 0. So this form is called rational expression. That is an expression that is the ratio of two polynomials. When two polynomials written in the ratio form, this is called rational expression. You can say x square plus 5 over x plus 3. This is a ratio form. Here the top one is the numerator, denominator the bottom one, and both are the polynomials, and bottom one is not equal to 0. So this ratio form is called rational expression. Note: every polynomial p of x can be regarded as a rational expression, since we can write p of x as p of x over 1, because every polynomial can be written as p of x over 1. So every polynomial is a rational expression. Thus every polynomial is a rational expression, but every rational expression need not to be a polynomial. Keep this in mind. We are going to solve exercise 4.1, question number 1, that is, identify whether the following algebraic expressions are polynomial. We are going to write yes or no. We are going to identify that the expression, the algebraic expression that are given, either they are polynomial or not. The first one, 3x square plus 1 over x minus y. This is an algebraic expression, and you can observe that in the second term it is 1 over x, that the variable is divided. whenever the variable is in the division form, this is not a polynomial. So not a polynomial as no division by a variable is allowed. Next, 3x cube minus 4x square minus x square root of x plus 3. You can observe in the third term, that is x square root of x, square root of x, again x raised to power 1 by 2. So that is a non-negative, that is not a non-negative integer now, because this is 1 by 2. So not a polynomial as a variable's exponent can only be 0, 1, 2, 3, so on, etc. So x raised to power any fraction is not allowed. Third part, x square minus 3x plus square root of 2. You can observe that the first term, that is x square, allowed, minus 3x allowed, plus square root of 2. Square root of 2 is a constant. So yes, this is a polynomial as square root of 2 is allowed because it is a constant. It has the value 1.4142, etc. Fourth one, 3x over 2x minus 1 plus 8. Not a polynomial. This is a rational expression, 3x over 2x minus 1. But not a polynomial because dividing by a variable is not allowed. Question number 2. State whether each of the following expression is rational expression or not. The first one, 3 square root of x over 3 square root of x plus 5. Now you can observe the top and the bottom are not the polynomials. So a square root of a variable is not allowed, we know that. And when top and bottom are not the polynomials, then this is not a rational expression. Next, x cube minus 2x square plus square root of 3 over 2 plus 3x minus x square. You can observe top one, that is a polynomial, and the bottom one is also a polynomial. So this is a rational expression because both denominator and numerator are the polynomials. Next one, x square plus 6x plus 9 over x square minus 9. So this is also a rational expression. Both numerator and denominator are polynomials. Fourth one, 2 square root of x plus 3 over 2 square root of x minus 3. The top and bottom are not polynomials as square root of a variable is not allowed. So if the top and bottom are not the polynomials, so this is not a rational expression. Now students, I hope you can solve exercise 4.1 question number 1 and 2 and learn all these definitions, all these concepts. Fi aman Allah.